Hey guys, it's Miss Agar. Today we are going to talk about water in the atmosphere. We've already learned about wind in the atmosphere, now we're moving into water. And there's two major points today. The first one is cloud formation. The second is precipitation. Both of these are directly related to the water cycle, which most of you know quite a lot about already. You probably learned about the water cycle in 4th grade or so. Two major points when we're thinking about cloud formation and precipitation. The first one is energy. So we need energy to make this whole thing work. In our atmosphere, energy is going to be in the form of solar energy coming from the sun. We've talked about that infrared radiation. The second thing is gravity. So when we're talking about precipitation, we need gravity around to help pull the precipitation back down toward the earth. So energy and gravity. First we'll talk about cloud formation. So as you see in the picture on the right, if we have some air that is warm, it's going to rise up. And that warm air is also going to contain water vapor, so that water vapor will rise up into the air, or rise up with the air, until it runs into an area of cooler air. When we have that water vapor up near the cooler air, when we reach a specific temperature that we call the dew point, that colder air and the water in it, when they reach that dew point, condensation is going to occur. Condensation. So the reason that happens is colder air just can't hold as much moisture as the warmer air does. So as the water vapor reaches that cooler air, the water vapor condenses and forms a liquid or an ice crystal. Now, water vapor can't just turn into some sort of particle on its own. It usually needs to attach to some sort of particle in the air. It needs something to condense on. So that water vapor will usually find something like dust or smoke or some sort of solid in the air to condense on. So if that warm air rising, the water vapor rising, it reaches the cooler air. When it reaches its dew point, those water droplets are going to start to form, and they need to form on some sort of particle. They need a particle to condense on. You can probably think of an example. The best one that I can think of is when you get out of the shower, that warm air coming from your hot shower will often be seen condensing on the walls or maybe the mirror in your bathroom, condensing on that cooler surface. Here you see a picture of clouds. So in talking about cloud formation, there are two major things to be aware of, and that is both the shape of the clouds and also their altitude. So clouds form in lots of shapes and sizes, and on the far right you see the cumulonimbus, that big cloud over there. There's also some smaller stratocumulus clouds, and then way up at the top you see those wispy cirrus clouds. And there's two main ways to classify clouds, and that is by both shape and by altitude. So first, if we're talking about shape, you see the cumulus, cirrus, and stratus. Those three different shapes are what we use to classify the shapes of clouds. We also like to talk about the altitude of clouds. So way up at the top, you see that this diagram is divided into three parts. The high clouds we usually think of as being cirrus clouds, those really thin, wispy horsetails. In the middle clouds, you see the altocumulus and altostratus. That alto prefix is used for middle clouds. And then down at the bottom, the low clouds, you see that nimbostratus cloud right there. That is associated with precipitation. They also, when we're thinking about low clouds, you'll see the word stratus a lot. And when you hear stratus, you should be thinking about layers. Those clouds have lots of layers. If you have ever heard about rock layers, you'll sometimes hear the word stratification, or that the rock is stratified. So stratus, you're thinking about layers. On the right side, there's that big cumulonimbus cloud, and that is often associated with dangerous precipitation like storms. Now we're moving into types of precipitation, and you probably know quite a few of these already. So take a moment, just brainstorm. You can pause the video for a second. See how many kinds of types of precipitation you can come up with. Alright, so here you see 5 different types of precipitation: rain, snow, sleet, hail, and drizzle. Yes, drizzle is actually a scientific term that scientists and weathermen will use. Here we have different sizes of precipitation and cloud droplets. So starting on the far right, cloud droplets are very, very small. You'll see they're only like 0.05 millimeters, so very, very tiny. When we start getting into that drizzle, they are a little bit bigger, and that's when they become too heavy to remain up in the sky and will start to fall. Raindrops are 2 millimeters, so quite a bit larger. And then snowflakes are one of the largest types of precipitation. Here you see a picture of freezing rain. Freezing rain is not classified as a type of precipitation. We just would call this rain because rain falls from the sky and it doesn't become freezing rain until it actually reaches a cold surface on the ground. Once it hits that cold surface, then obviously it turns into freezing rain, and that can create some pretty dangerous situations like you see here, because that freezing rain adds a lot of weight to objects. But we just talk about this as rain falling as a liquid until it freezes when it comes into contact with a cooler surface. Here you see an image of a car with freezing rain. If my car looked like this, I would not be coming to school that day. It would be your lucky day. All right, moving on, I want to talk to you a little bit about hail. You're going to be doing a lab in class, the hail lab, in which you'll actually be able to make some hail, so that will be pretty cool. Hail typically comes from cumulonimbus clouds like you see here. Warm updrafts are going to send water droplets up through that cloud, and at some point gravity is going to take over and those droplets are going to become too heavy to be lifted up by those updrafts. When that happens, they're going to fall back down. Now this process ends up repeating itself over and over, the warm drafts bringing the water droplets up and them becoming heavy and falling back down as a hailstone. And every time that happens, the hailstone is going to be adding layers and layers of ice as it makes its way up and down through this cloud. All of these different layers are going to be adding on ice forming around that water vapor. If you took a hailstone and cut it in half, it would actually look kind of like an onion, and you'd be able to see all of those different layers that formed as that water vapor was being pushed up and back down the cloud. Finally, to review, just want to remember this whole video we've been thinking about clouds and precipitation. Remember that as the warm air rises and starts to cool down or run into a cooler air mass, and it cools down to its dew point, the water vapor cools to the dew point, condensation is going to start to happen. Only a certain amount of water can be held in the air, so as soon as that condensation, those water droplets become too big and those updrafts can't hold it up in the air anymore, gravity takes over and it's going to end up falling. There's that delicate balance between the updrafts keeping precipitation or water vapor lifted up into the air and the gravity pulling precipitation back down to the earth. At this time, if you have any questions at all for me about water, anything, you need to come and see me.